As physical scientists, we need to be aware of the social aspects and political aspects of how we project the future and how we provide pathways and so on. As modelers, we tend to get very fascinated with the models and the scenarios and future projections and begin to assume that they are reality, and that's exactly how we will evolve. But they lead to unintended consequences like setting a climate deadline. For example, models showed that cumulative emissions can be linearly correlated to warming, and this means if you set a target like 1.5 degrees C or 2 degrees C by 2100, you can estimate how much more cumulative CO2 room is left. And then you can take current emission per year and try to estimate how many years before we hit that or before we use up that remaining cumulative emissions allowed. But this hides a lot of details about the uncertainties in the carbon cycles and how the future may evolve and so on. So this is a cautionary tale on why setting a climate deadline is dangerous, because UN Secretary General and the political heroes like Greta Thunberg began to say things like, we have only 11 years or 13 years or 7 years left to save ourselves, to save the planet, and so on. This says that the publication of the IPCC special report on global warming of 1.5 degrees C paved the way for the rise of political rhetoric of setting a fixed deadline for decisive actions on climate change. However, the dangers of such deadline rhetoric suggest the need for IPCC to take responsibility for its report and openly challenge the credibility of such a deadline. The planet is not going anywhere, biology is not going anywhere, we are facing a severe challenge, but setting such a deadline has all kinds of unintended consequences as well, and that's not what IPCC meant to do either. Moving towards the main message of this podcast, let's look at another cautionary tale, betting on negative emissions. Bioenergy with carbon capture and storage, which is now used more and more in the scenarios, could be used to remove carbon dioxide from the atmosphere. Obviously, that's theoretically true. However, the credibility of BECCS as a climate change mitigation option is unproven, and its widespread deployment in climate stabilization scenarios might become a dangerous distraction. So that brings me to the main paper that got published here in 2014, as well as the co-evolution of technological promises, modeling, policies, and climate change targets. And read the abstract, which is very telling. The nature and framing of climate targets in international politics has changed substantially since their early expressions in the 1980s. Here we describe their evolution in 5 phases, from climate stabilization to specific temperature outcomes like the 2 degrees C warming. There's a bit of a breeze here, so hopefully the sound is not too bad. Co-evolving with wider climate politics and policy, modeling methods and scenarios, and technological promises from nuclear power to carbon removal. They are technological promises because they are not proven technologies, not ready for implementation, not ready at all in some cases. We argue that this co-evolution has enabled policy prevarication, lying, leaving mitigation poorly delivered, yet the technological promises often remain buried in the models used to inform policy. We conclude with a call to recognize and break this pattern to unleash more effective and just climate policy. Okay, so the phase diagrams shown are very useful. This is the quadrant for negotiations with public debate. These are the global warming targets and metrics. These are the technological promises, innovations, and future proposals for deployment at scale based on how much CO2 needs to be extracted. And these are the modeling frameworks that are available and the scenarios that are used to inform policy decisions and negotiations. So in phase 1, we started with the idea of stabilization, which included political jockeying over responsibilities, started with Earth Summit Rio, UNFCCC, really made lots of news. And then came vague formulations awaiting clear targets, because stabilization and avoiding dangerous anthropogenic climate change were not that well defined. Models were not as sophisticated as at present, and that led to interactions between enhanced sinks, nuclear power, energy efficiency, helping to decide on pathways to stabilization and avoiding dangerous anthropogenic climate change. And of course, we were dealing with early general climate circulation models with special scenarios, SA90, IS92, and so on, that most people of the present generation will not even remember. But these were crude representations eliciting large-scale interventions. Then came phase 2, which started to move towards percentage emissions cuts, leading to Kyoto Protocol in 1997. But the percentage emission cuts by date were the goal. It was kind of top-down, not as democratic as the Paris Agreement, for example. And this focused on relative to future emission levels projected in scenarios. What would be the percentage cut emission needed at set pathways in the future? And the technology included focus on efficiency, fuel switching, carbon capture and sequestration already became mentioned and started to play a bigger role. And technologies that promise percentage cuts in fossil fuel emissions started to come along. Since then, there's been a lot of knowledge about how much space we really have in terms of using efficiency advances to reduce emissions, especially after the so-called rebound effect, where more efficient things may lead to more consumption, and the fact that CCS still remains unproven at scale, and without worrying about whether, assuming that future CCS technologies will really work, there was some political rhetoric beginning to allow more fossil fuel consumption, continued fossil fuel exploration, and using future technological promises to keep going with business as usual. And this again should remind us that despite the 25-year negotiations, we are basically on the business as usual emission scenario, with no hint of reducing emissions, and whatever little dip we had because of COVID and the lockdowns is now more than recovered into 2021 and 2022. So then here came the early integrated assessment models and emerging special report on emission scenarios, which led to growth-based scenarios eliciting efficiency and fuel switching. So here models began to lead the technology. They started to depend on technologies like CCS to say how we can get to the promised land of percentage emission cuts. And that led to Kyoto Protocol, and targets were agreed on for emission cuts, but we know that it's basically a complete failure. It ended in 2012 with no real accomplishments. Then came phase 3 with focusing on atmospheric concentrations. So debate over safe levels, 350 or 450 ppm. There was James Hansen arguing that 350 ppm is what is safe and anything else is just dangerous and bad. Here we are already above 420 and still going with life as usual. And that came again with technological promises of carbon capture sequestration, but also early efforts at so-called bioenergy and carbon capture and sequestration, without worrying about all the consequences or even feasibility of bioenergy. How much land would it need? How would it compete with food security? How would it affect water use, water contamination, land use emissions, and so on? So imaginaries of Beck's promise to act directly on concentrations started to feed into the targets there. And again, integrated assessment models played a bigger role in designing the next set of scenarios called the representative concentration pathways, which depended on, of course, using all the assumptions of projecting to the future about population, energy mixes, food production, transportation, cement production, etc., to say what the net radiation imbalance will be at the end of 2100 and what are the safe levels and so on, without mentioning temperature targets at this point. So models cost optimized with slow migration and much CCS and BECCS were playing a bigger role, leading to Copenhagen, which ended up in basically a lack of agreement because the 2°C warming target was already agreed upon here, but there were many discords and the meeting ended without agreement. So the disagreement over targets and metrics ended up calling this as a failure, many aiming for 450 ppm and many countries not agreeing. But then there was retrospective claims that actually much progress was made and so on and so forth. But the fact is we had to then get to phase 4 where we started to focus on cumulative budgets. Some seminal work from Miles Allen came along and showed that it's the cumulative emission from the Industrial Revolution that is adding each degree of warming, each ton of additional CO2 contributing to warming. So here live scientific debate eliciting new options in models came along to focus on the additional trillion ton of CO2 and so on. So cumulative emissions budgets became the targets. They again relied on the technological promise of BECCS, bioenergy and carbon capture and sequestration, and even more dangerous terminology of negative emission technologies came along. So technologies parameters largely defined by the models. So here models began to get better at carbon cycle impact on climate, feedback from climate to carbon cycle, vegetation dynamics, etc. And this began to allow models to include more and more of these technologies like BECCS and NETS to say how we can actually meet our cumulative emissions targets. So this led to carbon budget models and inverted IAMs, budgets balanced using negative emissions without having any demonstrated technologies in place. That led to Durban and Doha talks. So inconclusive and contested scenarios and solutions happened here, but we keep marching forward. So outcome now focuses on temperatures. So temperature outcomes 1.2°C target was decided as a good one, which in fact comes out of Bill Nordhaus's economics work from the 1970s, taken up by the European Union and the Stern report, and then retrofitted for consequences based on some paleoclimate evidences and modeling for the future. Still not really robustly scientific choice. And again, they depended on net negative emission technologies, but now more and more about solar radiation management and geoengineering began to play a role, again based on modeling abilities to say how we can safely do solar radiation management or spraying aerosols into the stratosphere, because looking at the models we can say we can avoid droughts, we can avoid extreme events, we can avoid GDP losses and so on and so forth. So Imaginaries promise to reverse, overshoot, manipulate temperatures, leading to so-called shared socioeconomic pathways linked to Earth system models, which became much more sophisticated in terms of including biochemistry and feedbacks and so on. So here temperatures linked to emissions and scenarios and resolutions of these ESMs got much better compared to CMIP 3 and CMIP 4, now CMIP 5 and CMIP 6, but you will always find series of papers to trying to quantify the improvements in each generation of models, and if you read carefully you are only tinkering at the edges, that there are no dramatic improvements in anything like El Nino, monsoon or other natural variabilities which are very critical to project into the future with all these scenarios. Anyway, that led to Paris Accord agreement enabled by BECCS rich scenarios, which are still not feasibility demonstrated or ready for implementation, and so on and so forth. So where does that leave us? I want to add one more little item here before I move on. maybe I won't add more. It's already long enough. So basically just remember that model and model proficiencies and model improvements are now allowing us to include non-existent technologies as potential pathways to meeting the various targets along the way, whether it's cumulative emissions or temperature warming targets. But this paper that I just showed from 2014 argues that these have evolved kind of disconnected from actual technology innovations and developments and implementations and so on. So the biggest CCS that is going on, let's say installed in Iceland, removes about 800 cars off the road per year. That is a tiny amount. But when we have talked about emissions gaps and so on, we have looked at how carbon drawdown has to go if we want to meet these targets. Okay, so right now we are not even remotely close to being on any of those pathways. So all the good things continue to happen. In the investments in renewables continue, investments in electrification continue. But if you keep tracking carefully the progress, electric vehicles are growing in number, but not at a scale that is significantly reducing fossil fuel consumptions by internal combustion engines. Renewables are growing, but they are very far from replacing fossil fuels. In fact, there is no indication that by 2050 we'll be completely free of fossil fuels. But by then you expect negative emission technologies to kick in and start drawing down more CO2 than we emit. But this is still just a promise. Is that a promise or is that a political prevarication? This is the key question. Do these models demonstrating feasible technologies and their impact on drawdown in fact delay mitigation efforts by using these political prevarications? This is what is the cautionary tale of this podcast. Okay?